Hello friends, welcome to my channel Academic Made Easy PC. If you have not subscribed my channel, subscribe it and also click the bell icon. In this video, we will be learning exercise 2.2 from the chapter Inverse Trigonometric Functions. In this exercise, we will be learning with the elementary properties which I taught you in the introduction part. We will be applying all those properties to prove or find or simplify the given problems. Okay, so this exercise is very easy if you have learnt those elementary properties for inverse as well as trigonometric functions. If you have not watched that video, please do watch it. I will attach the link in the description box. So now we will move on to the questions. Prove the following. Question 1. 3 sine inverse x is equal to sine inverse of 3x minus 4x cube. So this is only the formula that we learned, isn't it? You may think, how can we prove this? Then now, there is one more method. I said no. Simply just like that, we cannot prove with the inverse trigonometric functions also. So we have to use the normal trigonometric functions, which I thought no important properties. We have to apply those properties to prove that LHS is equal to RHS. So here now we have to check in which form this RHS, mostly RHS you use, so that it will be very easy for you all. So you just use this RHS. So it is of the form 3x minus 4x cube. So this is of the form 3 sin x minus 4 sin cube x. No. So now let me say that x is equal to sin theta. Now I have to substitute the value for x as sin theta. So now let me take only RHS. So I am taking only RHS. Then my value of x will be sin theta. So my theta will be sin inverse x. This also I am writing it in the beginning itself. So my RHS is sin inverse of 3x minus 4x cube, isn't it? So therefore I will write sin inverse of 3. What is this? X is sin theta. No, so sin theta minus 4 sin cube theta. Okay, so now I will write that 3 sin theta minus 4 sin cube theta is equal to sin 3 theta. Okay, so now I will substitute here it as sin 3 theta. So sin inverse of sin 3 theta. So here this is of the form sin inverse means what? 1 by sin. No, that only simply we are writing it as sin inverse. So sin by sin will be 1 only. No, so therefore I will cancel these two and write only 3 theta. So now I have already said what is my theta, the value of theta. No, so therefore 3 into what is my theta? Sin inverse x. So sin inverse x, where I got 3 sin inverse x. Is this equal to my LHS? So therefore I will say that this is equal to LHS. So LHS is equal to RHS, hence proved. Now let's move on to question 2. 3 cos inverse x is equal to cos inverse 4x cube minus 3x. This is very similar to the previous sum. So now I am taking only RHS. So here also when I see here 4 cos cube x minus 3 cos x is equal to cos 3x. No, so this is of that form. So let me take here x as cos theta. So this implies my theta will be cos inverse x. Okay, so now let me substitute over here. So cos inverse of 4x cube minus 3x is equal to cos inverse of, what is my x here? It is cos theta, no? So cos cube theta minus 3 cos theta. So here already I said 4 cos cube theta minus 3 cos theta is cos 3 theta, no? So I will substitute directly. So cos 3 theta. So cos and cos inverse will get cancelled. So this will be 3 theta. So what is the value of theta over here? It is cos inverse x, no? So 3 into cos inverse x. So here my LHS is 3 cos inverse x, and my RHS also I proved it is minus, that is 3 cos inverse x, no? So therefore it is equal to LHS, that is left hand side, hence it is proved. Let's move on to question 3. Tan inverse of 2 by 11 plus tan inverse of 7 by 24 is equal to tan inverse of 1 by 2. This is a given question. So already in the formula we have learnt what is tan inverse x plus tan inverse y. Now we will be applying that formula. Tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy. So we'll just directly apply this in the given question. So what is a tan inverse x? This will be a tan inverse x and this will be a tan inverse y. Taking only LHS. So tan inverse 2 by 11 plus tan inverse 7 by 24 is equal to, I will apply this formula. So therefore I will have tan inverse 2 by 11 plus 7 by 24 divided by 1 minus 2 into 7 by 11 into 24. I'm just applying this formula directly. So next step I will have tan inverse. So here I am cross multiplying it. So I will have 48 plus 77 divided by 11 into 24 divided by 11 into 24 is 264 minus 14 divided by 11 into 24. So here denominator both also is same, so I will cancel these two. So therefore I will have tan inverse of 125. If I add this I will get 125 divided by 250. So now I will cancel because these two are have common terms, no? So therefore I will be cancelling. So I will get 2550. So 25 1 times 25, 25 2 times 50. So therefore it will be tan inverse 1 by 2 equal to RHS. Question 4. 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is equal to tan inverse 31 by 17. Even this is similar to previous sum, but there is a slight change in it. Okay, so you have to check the coefficient also. Coefficient for only for this here it is 2, no? So it is just similar to 2 tan inverse x. So if we have tan inverse alone, then we can apply the direct formula. If not, we have to convert it, then only we can apply the formula. So already we have learnt 2 tan inverse x is equal to tan inverse 2x divided by 1 minus x square. No, so we will be applying this formula, then we will convert it. So 2 tan inverse 1 by 2 is equal to tan inverse 2 into 1 by 2 divided by 1 minus 1 by 2 the whole square. So this will be my formula. So here next I will have tan inverse. So this 2 and 2 will get cancelled. So 1 upon. So here if I cross multiply or I take LCM here, I will have 4 minus 1 by 4. So now I will be taking reciprocal. So I will have tan inverse of 4 by 3. So this is my answer for 2 tan inverse 1 by 2. So now I will be applying this in the question. So in the place of 2 tan inverse 1 by 2, I will be substituting this one. So my LHS will be 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is equal to tan inverse 4 by 3 plus tan inverse 1 by 7. So now this is of the form tan inverse x plus tan inverse y. No. So we will be applying that formula tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy. So this is the formula that will be applied over here. So we will have tan inverse of 4 by 3 plus 1 by 7 divided by 1 minus 4 by 3 into 1 by 7 multiplication. So in the next step, we will be having tan inverse of, so I will take LCM for this. So I will have 28 plus 3 by 21 upon 21 minus 4 by 21. So here also my denominators are same, so I will cancel these two. So I will have tan inverse of, so 28 plus 3 is 31 divided by 21 minus 4 is 17. So this equals my RHS, so hence proved. Here they asked to prove that LHS is equal to RHS, no? So therefore mine is proved. Write the following functions in simplest form. So here some functions will be given and we have to find the simplest form for the given function. Okay, so even this is very easy, and here one important thing is that we will be using the normal trigonometric functions without inverse. So we have to be very clear. As I said in the introduction part, I gave some important properties, no? That properties only we will be mostly using in this type of questions. So we have to be very clear with the basic concept. So now let's move on. Question 5. Tan inverse of root of 1 plus x square minus 1 by x. So no clue will be given in the question. We have to think and we have to apply all the properties to get the function in the simplest form. Okay, so now we have to check in the numerator first, or wherever we have a biggest sum, like here it is root of 1 plus x square minus 1, no? So here it is big, just like equation, no? So here it is bigger one, so we will be checking for this first. So here 1 plus x square, in what form can we take? 1 plus tan square we can take, no? Since here I have tan, I will be taking 1 plus tan square, no? So therefore, so now let's get started with the solution. So now I will be writing x is equal to tan theta. Okay, so however it is favoring the question, we will be applying it. So also I'm writing theta is equal to tan inverse x. So I'm just taking the tan inverse to the left hand side. So only I have written theta is equal to tan inverse x. So now let's substitute in the given function, that is tan inverse root of 1 plus x square minus 1 divided by x. So therefore applying this one, I will have tan inverse of root of 1 plus tan square theta. Since my value of x is tan and theta, for x square I'll have tan square theta minus 1 divided by tan theta. So therefore I will have tan inverse of, what is 1 plus tan square theta? Root of secant square theta. No, secant square theta minus 1 by tan theta. So in the next step, I will be having tan inverse of root of secant square theta is square and square root gets cancelled. So secant theta minus 1 by tan theta I will have. No. So in the next step what is secant theta? 1 by cos theta is secant theta. What is tan theta? Sin theta by cos theta is tan theta. So therefore tan inverse of 1 by cos theta minus 1 divided by sin theta by cos theta. So tan inverse of, now we will be taking LCM. So I have 1 minus cos theta divided by cos theta, the whole divided by sin theta divided by cos theta. So here cos theta and cos theta is common. I mean the denominator is same, so I will cancel these two. So tan inverse of 1 minus cos theta divided by sin theta. So see here, I already said you we may have cos 2 theta or cos theta, however it is, we will be changing it. So here 1 minus cos theta, it means, see here we have cos 2 theta is equal to 1 minus 2 sin theta, sin square theta. No. So here when I take this 2 sin square theta, this side sin square theta is equal to 1 minus cos 2 theta. No. So this is of the form like this. Only thing is that 2 is not there. So I will be writing tan inverse of 2 sin square theta by 2. Fine. Here since 2 theta is here only theta. So when I have only theta here, it should be theta by 2. No, so only. And here when you see if I directly write here sin theta, I can't do anything. Why? Because I have theta by 2 here. But here only theta is there. So I have to change this also. No. So I also have a formula sin 2 theta is equal to 2 sin theta cos theta. So cos theta. So here only theta is there. So what will I get? 2 sin theta by 2 into cos theta by 2. No, so I will have sin theta by 2 cos theta by 2. So 2 and 2 will get cancelled, and here sin theta by 2 and sin theta by 2 will get cancelled. So I will have tan inverse of sin theta by 2 divided by cos theta by 2. So sin theta by cos theta is tan theta. No. So tan inverse of tan theta by 2. So tan inverse and tan will get cancelled. So I will have theta by 2 alone. So already we have found what is the value of theta. No? Theta value is tan inverse. So tan inverse x divided by 2. So that is half tan inverse x. So therefore the simplest form for tan inverse of root 1 plus x square minus 1 by x is half tan inverse x. Question 6. Tan inverse of 1 by root of x square minus 1 where mod x is greater than 1. So here, so when we take like this, here only we have some clue. Okay, so we will be taking denominator over here. It's not that always we have to check only in the numerator. We can also check in denominator. So whichever part is favoring the question, we will be taking. Okay, so it does not depend on numerator or denominator. It depends on the equation of function which is given. So whichever is favoring the question, we will be taking that. So since here denominator only we can do something. No, so only we are taking denominator. So here it gives us some clue. Look, when you see the equation, you will get an idea, isn't it? So here what was my idea is that secant square x minus 1 is equal to tan square x now. So only I thought let me take x as secant theta. So here I will be taking x is equal to secant theta. So which implies what is my theta now? As we did for the previous question, this will be secant inverse x. So now we will be substituting in the given equation. So here what tan inverse 1 by root of x square minus 1 is equal to tan inverse of, in place of x we will be substituting secant theta. Okay, so 1 by root of secant square theta minus 1. So next step, tan inverse of 1 by root of tan square theta. So you just mention the formulas whichever you are using. Okay, so secant square theta minus 1 is equal to tan square theta. So if you mention what all formulas if you are using here, no, you will be having mark. If you see the marking scheme, no, this may be for half a mark. Okay, so when we write formulas we will be getting half mark. So now tan inverse of 1 by root of tan square theta. So square and root will get cancelled. So we will have tan inverse of 1 by tan theta. So what is 1 by tan theta? Cot theta. So here inside this bracket or in the function we need not to use inverse and all. In tan inverse and 1 by tan theta is same. But inside the brackets we need not to go with inverse because that is a very long method. So we'll make it simple so that I'm taking it as cot theta. Fine. Now we know that cot theta is equal to tan pi by 2 minus theta, or cot theta is equal to tan 90 minus theta. No. So this is the formula which we will be applying to make it simple. So now we will be taking this one. So since we are dealing with tan pi by 2 and theta, no, so we will be taking tan inverse of tan pi by 2 minus theta. Fine, I have changed this cot theta to tan pi by 2 minus theta. So here tan and tan inverse will get cancelled. So now what will I have? Only pi by 2 minus theta. So now already we have found what is theta, no? So what is theta? Secant inverse x. Secant inverse x. So pi by 2 minus secant inverse x is the simplest form. Over. Question 7. Tan inverse of root of 1 minus cos x divided by 1 plus cos x. So here, as we did for the previous sums, we can't just substitute the value for x. Okay. So why? Because it is in the form of cos x. So that is not possible. So now we have to check in which form or which formula can we use it to simplify. Okay. So we have to be very thorough with the properties that I gave you. Okay. So now when we look at these properties, we will have an idea, because see, cos x is equal to 2 cos square x by 2 minus 1, and if it is like this, no, so cos x plus 1 is equal to 2 cos square x by 2. This one is in the denominator, no? So for this numerator we will be having cos x minus 1 is equal to 2 sine square x by 2. So I have already taught all these formulas in the introduction part. So only I'm just directly doing it. Okay. So if you have any further doubts, please do verify with that. I will attach the link in the description box. So now we will be substituting these values in the given function. What is the function? Tan inverse of 1 minus cos x divided by 1 plus cos x, which is in root. So this will be tan inverse of root of, what is 1 minus cos x is 2 sine square x by 2, and what is 1 plus cos x? It is 2 cos square x by 2. Cos square x by 2. So now this is division, so 2 and 2 will get cancelled. So now what is sine square by cos square? It is tan square. So tan inverse of root of tan square x by 2. So root of tan square x by 2 means, so root and square will get cancelled. So I will have tan inverse of tan x by 2. So therefore tan and tan inverse will get cancelled. So what will be my answer? X by 2. So this is my answer. Question 8. Tan inverse of cos x minus sin x divided by cos x plus sin x. So here we don't have any clue to just simplify it, no. So if we take conjugate also, we will be having cos x minus sin x into cos x minus sin x. Then we will have cos x minus sin the whole square. So which is not possible. So we'll just simplify it very clearly. So here we have tan inverse. So if we have tan, we can directly cancel, no. So that we will try to make any one of the terms to tan, so that we can convert everything to tan. So I will have solution. So to make it tan, I have to get sine by cos. Now, so how to get sine by cos? Then I have to divide throughout by cos, isn't it? So therefore, I will divide throughout by cos. So dividing throughout means each and every term by cos x. So therefore, tan inverse of cos x minus sin x divided by cos x plus sin x is equal to tan inverse of cos x by cos x. So each and every term knows only. So sin x by cos x whole divided by cos x by cos x plus sin x by cos x. Fine. So now cos and cos will get cancelled. Cos by cos will get cancelled. So in the next step, I will have tan inverse of 1 minus, what is sin x by cos x? It is tan x, no? So tan x divided by 1 plus tan x. So now we will get a clue. See, already we have did so many sums with this one. So it is very easy for us to identify. No? So here I have 1 minus tan x divided by 1 plus tan x. See, my y will be tan pi by 4. What is tan pi by 4? It is 1. So therefore, I will substitute the value for 1 is equal to tan pi by 4. So we have already learnt all these in class 11. So only directly I'm just writing this. So here, what is tan pi by 4? It is 1. So to make it simplify, I'm writing this. So tan inverse of tan pi by 4 minus tan x divided by 1 plus tan pi by 4 tan x. Fine. So here tan pi by 4 is 1. So we will get back the previous step. So here I will have tan inverse of, so what is this here? It is just like tan x. So tan x minus y. This is of the form tan x minus y, no? So which is equal to tan x minus tan y divided by 1 plus tan x into tan y, no? This is of this form. So I will have tan inverse of then what is my x here? Pi by 4. No. So pi by 4 minus x. So I got it in the form of tan. No. So here tan and tan will get cancelled. So therefore I will have only pi by 4 minus x. So this is my simplified form of the given function. Question 9. Tan inverse of x divided by root of a square minus x square where mod x is less than a. So here the given a is some constant. Fine. So in the simplest form, we should not have any constants remaining. So we have to try to remove the constant. Fine. So here in order to remove the constant, if we substitute any value, then we have to have this constant also. So in order to cancel out in numerator and denominator. So here only in denominator we have, if we substitute any value, this a might get cancelled. No? So we have to check like that. So here I have a square minus x square. Just leave out this a. Fine. Since because like we will be substituting over here also for a. So here it will be a square only. So we will take a out. Then it will be 1 minus something. No. So how if we do like what we will get? Tan we have to check. Okay. So I have an idea like let my x value be a sine theta. Oh, okay. Next, it will be x by a is equal to sine theta, where my theta value will be sine inverse of x by a. This will be my theta value. So this I will substitute in the function. So if I substitute like that, I will have a square sine square theta. So that my a will be taken as common out. If I take it out of the root, I will have only a. So here if I substitute also, I will cancel here. So a and a will get cancelled. So you have to think like that and then answer. So if I start substituting here, so I will write tan inverse of x by root of a square minus x square. So if I start substituting, I will have what is my x value? A sine theta, isn't it? So a sine theta divided by root of a square minus here it is x square. No, so if it is x square, I will have a square sine square theta. Fine. So a square sine square theta is there. So now I have a common. No? So I can take it out. So tan inverse of a sine theta divided by root of a square into 1 minus sine square theta. So here this is of the form sine by cos. What is 1 minus sine square theta? It is cos square theta. Since it is under the root, I will take only cos so that I will get my tan. So only I have substituted like this. So next step I will bring this a square out of the root. So here square and root will get cancelled. So tan inverse a sine theta divided by a root of what is 1 minus sine square theta? 1 minus sine square theta is equal to cos square theta. So here I will have cos square theta. So then in the next step I will have a and a gets cancelled. So tan inverse of sine theta divided by root and square gets cancelled. So cos theta. So what is sine theta by cos theta? It is tan theta. Tan inverse of tan theta. So tan inverse and tan will get cancelled. So only I have theta as remaining. So already we have found what is the value of theta, isn't it? The value of theta is sine inverse of x by a. see, the constant can be here as the value of sine, but not in before or after sine. Okay, this is a function of sine. So x by a. So here we can have the constant but not before or after the sine. Fine. So this is the simplified form. Tan inverse of 3a square x minus x cube divided by a cube minus 3ax square, where a is greater than 0 and minus a by root 3 less than equal to x less than equal to a by root 3. So this is the given function or question for us. So we have to find the simplified form for this. So here also, as we did for the previous sum, we have to remove this constant a. So in order to cancel out this a, we have to substitute in such a way that this a gets cancelled. So see, this is of the form 3 tan x minus a tan cube divided by 1 minus 3 tan square x. No, so if you just see the formula itself, we can identify it is in which form. So it is directly given, so that only thing is that we have to remove a. So in order to remove a, we have to substitute in such a way. So here when you add the powers of a and x, you will get, see, I have 2 plus 1, which is cube, 3. Here also 3. 1 plus 2, 3. So I should have the powers of a as 3. So I have to substitute x as x is equal to a tan theta. So this should be my substitution. So now here itself I'll find what is theta also. So x by a is equal to tan theta. So my theta is equal to tan inverse x by a. So this is my value for theta. So now let's start substituting in the given function. Tan inverse of 3a square x minus x cube divided by a cube minus 3ax square. So now I will start substituting the value of x. So tan inverse of 3a square, what is my x? A tan theta, no. So a tan theta minus a tan theta the whole cube divided by a cube minus 3a tan theta square. So now we'll simplify. So tan inverse 3a cube tan theta minus a cube. Here this is multiplication, no? So only. So a cube tan cube theta divided by a cube minus 3. This is a, and I will have a square here. So a into a square is a cube. So a cube tan square theta. So now I can take all my a cube common out. No, so I will have tan inverse of a cube divided by a cube. This also I am taking it out, both in numerator as well as denominator. So I will have 3 tan theta minus tan cube theta divided by 1 minus c. I took this out, no, so I will have 1 3 tan square theta. So here numerator and denominator is same, so I can cancel these two. And next step I will write 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta is equal to tan 3 theta. Yes, no, this is a formula. So if you write this formula, you may get 1/2 a mark. So tan inverse of tan 3 theta. Tan and tan inverse will get cancelled. So here I will have 3 theta. So already we have found the value of 3 theta, isn't it? So 3 into what is theta value? Tan inverse of x by a. So this is the required simplified form for the given question. So I will make one more video with full marking scheme. Okay, I will also upload some important questions chapter wise as we finish one chapter. Okay, so please do subscribe my channel so that you will get notified whenever I upload a new video. If you have any doubts, mention it in the comment box.
Like, comment, share and subscribe.